Okay, thank you, Tui. Oh, and there's Miranda. Okay, wonderful. All right. All hands on deck. Excellent. 100% attendance. 100% attendance. That is wonderful. Okay. So Miranda, I was just saying, just be sure and log into Blackboard and do your attendance, and then be sure and get the today's online quiz done before the end of class. And yep, like after in about 50 minutes. Okay, so what I think I'll do, I will just dive right in. Let me get my screen shared here. And so as we've got someone's little one helping out. And okay, wonderful. Okay, so just some quick review. I'll just go over these really quickly just to make sure that they sort of make sense. This is sort of a start of reviewing for the test next week. But how many pounds are there in 3.5 kilograms? Me multiplying that by 2.2 if you don't understand where I got that. Be sure and review that type of thing. The number of centimeters, that'll be in 57 inches, multiplied by 2.54. Okay, you might not know the numbers, but you can see where I'm going with those. A number of kilograms in 30.4, of course, divide by 2.2. And aspirin, 5 milligrams per kilogram, has been prescribed to reduce the fever of an infant weighing 8.5 pounds. What is the number of milligrams? Okay, so of course we'll need to convert the number of pounds quickly. Convert that into kilograms. So we have 2.2 pounds per 1 kilogram, and we get that number, and then multiply that number times 5 milligrams per kilogram is the dose, number in kilograms, cross out, and then give you the dose in milligrams. Okay, so that kind of thing should be pretty intuitive at this point. An athlete with who weighs 65 kilograms, how many pounds of body fat? So of course that would be 65 kilograms times 1 kilogram is equivalent to 2.2 pounds. And then you would get that number in, of course, our kilograms cancel out, give us our weight in pounds. And then you multiply the weight in pounds by 3% or 0.03 to give you the number of pounds of fat. Okay. And let's see another pharmacy question here. Doses of ampicillin for an inner ear infection, 115 milligrams per kilogram of weight. What is the daily dose for a 35-pound child? That is exactly the same problem that we set up with just some different numbers and different medicine that we did in example 4 right there. Okay, convert it pounds to kilograms, and then multiply the milligrams per kilogram in a proper dosage to give you the proper dose to cure that ear infection. Okay, so let's look at matter and energy. A bit of a throwback here. That will approach the following way. So elements, we've seen this pretty extensively. An element is simply a collection of all the same atoms. Okay. And pure substances versus mixtures have just one composition, and mixture is other substances that can be physically mixed versus chemically combined. Okay, so let's take a quick peek at what I mean by physically versus chemically. Of course, an element is an example of a pure substance, as is water. That has a fixed ratio, distilled water. Same here with no solutes in it. Brass, however, is an indeterminate mixture of copper and zinc. And you could just drop some copper in water and have a heterogeneous mixture of water and copper in a glass of water. Now, pure substance, another example would be the aluminum in an aluminum can. Okay, pure substance. Compounds, which we have been touching on when we've been looking at chemical reactions, such as hydrogen peroxide, sodium chloride or salt. One of the types of sugars, we'll see more when we get into carbohydrates and organic chemistry, but you'll notice that a sugar, as I've been stressing, has carbon and hydrogen in this, a little oxygen mixed in. Is an organic compound, and then of course water is another compound that we have. Okay, so salt is a combination of the metal sodium and the gas chlorine, and it becomes the table salt that you have. So mixtures are heterogeneous mixtures. They are not chemically combined and can be separated out by physical processes. In this case, an example of the physical process is straining out the water and leaving the spaghetti behind. Okay, exact same idea. If we did have a lab, a chemistry lab, you would get to do this hands-on stuff, but you can think of it exactly the same way. You're using a physical process to separate out the components of a mixture. Okay, you can send it through a filter of various sizes, so you're left with only the thing that you're maybe trying to purify. I used to do this all the time when I was working in the medicinal chemistry department and at UW. And then chromatography is simply using the capillary movement up a medium to separate out different solutes that are in the solvent based on their molecular weight. Okay. Okay, so brass, like we already mentioned, is a homogeneous mixture of brass and copper all mixed together like that. And those, I usually have some people who are into scuba diving, so you probably will recognize some of this, of the different mixtures of gases that scuba divers use based on the depth that they're going to. And we'll come back to scuba diving when we're doing gases particularly. I think it's for subject right after the test. But nitrox is just a mixture of nitrogen and oxygen. Heliox, a mixture of helium and oxygen. Kind of interesting. I always find it interesting that we're perfectly happy breathing helium and oxygen. And trimix is when you put all three together, oxygen, helium, and nitrogen put together in various mixtures based on the type of scuba diving that you are doing. Okay. That's it for homogeneous mixtures. And heterogeneous is the things that are easily separated out, such as just putting copper in a glass of water, get the heterogeneous mixture of copper and water, like so. Okay, so let's see. Can someone tell me, I'll just go straight, is aluminum a pure substance or a mixture? Aluminum foil. Is everyone? It is, absolutely. As is helium. How about air? That is a mixture. Exactly right. Okay. So some of them, most things, these questions are fairly straightforward, but some of them can be a little tricky on the edges because people don't always think of air as a mixture of a bunch of stuff. Okay, and another example, heterogeneous mixture in a sundae. Shampoo is a homogeneous mixture. Sugar dissolved in water, completely dissolved. They're not extra, but considered as completely dissolved as a homogeneous mixture. And a pie would be heterogeneous. Okay, so silicon oxide is an example of a chemical, a combination of silica and oxide. Let's see, silica, double bond to a double bond, nice straight line. Interesting enough, also the primary component of sand on a beach, silica oxide, with some impurities mixed in. It's basically quartz with some impurities mixed in to make it amethyst. A lot of semi-precious stones are of that ilk. Okay, so like I said, we've been studying the bonds between silica and oxide. Um, just chemical bonds in general, primarily. And what makes them a solid is that they are in a lattice or crystalline arrangement at this temperature, and they really can't vibrate much. They do vibrate, but not that much, and they have a definite shape, volume, and mass for the most part. Okay. Okay. Second form of matter that we typically see is liquids have volume but not a definite shape. They will take on the shape of their container. That's one we see every day is water. The molecules can move more rapidly than they do in solids, but they move more rapidly, but not as fast as they do in gases, and they move in random directions called Brownian movement. And gases, which is where we will pick up after our test, they have an indefinite shape and volume, and there are laws that will go along with that account for the gaseous form of different molecules and elements. They assume the same shape and volume, importantly, as their container. They don't have the fixed volume like liquids do. And the molecules are really whizzing around quite rapidly. They're high-speed molecules and in random directions. Okay. And there's a fourth state of matter that I don't mention here, but I'm just wondering, does anyone know what another state of matter is if we keep adding energy to gases? See, has anyone heard of plasma? That's kind of interesting, an interesting subject. So do you see it? So if you've done some welding, plasma torches, all that kind of stuff, you're basically stripping the electrons. They've gotten so energetic that the electrons are coming off the molecules and bouncing around between various energy states. That is the fourth type of matter. But we'll stick with those first three because they're the ones that we see most of the time. Okay, there's a nice little table that accounts for all of those different types of matter that we typically see: solids, liquids, and of course gases, and their differences as far as their volume. Let's see how the particles are arranged, the interactions between the particles, the movements of the particles. Okay, so it has a definite volume but takes the shape of the container, would be a liquid. Particles are moving rapidly. Well, we'll go with gas, but liquid is moving more rapidly than they are in solids. They fill the entire volume of the container. That will be a gas because liquids will, under the influence of gravity, will only fill part of a volume if they don't fill it all the way to the top. So it's a little bit of a trick question. Fixed arrangement is solids, and close together but moving randomly. Here they're referring to liquids, of course. And I don't think so. Tablets, eye drops, liquid, solid. Like I say, this is a bit of an easier section for you guys. Okay, so 2 hydrogen buffalo plus an oxygen gives you a water buffalo. Bad jokes. But one of the great parts about being a dad is I get to tell dad jokes. Let's see if that's a good stopping place for us. Yeah, let's cut that short and we'll circle back to this because I do want to give you a little time in class to go over the upcoming test. And then a week from today will be essentially me answering questions about tests as well as any tutoring. If you guys want to get together and just have a study session on Tuesday at 1 o'clock, that will be great. No, I don't do that. I know some other professors do that, but I've found when I've tried to do that, no information really goes in, and I have to redo it anyway um, in the next class, honestly. So, ah, okay, here we go. Um, what was I going to say? Yeah, so yeah, typically, and I have this in one of my other classes, if I have to make up material, I just double down on one of my lectures. Okay, the midterm will get you 48 questions. Yep, total of 48 questions. Not yet. Not yet. I'm going to wait until I'm done with all the material that's going to be